Okay, welcome to class 24 enthusiasts. Today we are talking about IAM. And this class is kind of very, very interesting class because it's a peculiar class full of great minds. And today we are going to be focusing on IAM, IaaS. Public cloud provider always give 3 services. They give majorly 3 services. And despite they may try to expand these 3 services in different ways, however, these are the basic 3 services that public cloud provider gives. Now, what is a public cloud? Public cloud is just a company that have resources, IT resources stored in a big IT room known as data center. And they provide these resources to people to consume based on demand, and you pay as you go. Well, you can also go there and make a bulk payment. You can reserve some resources and you can pay by spot. There are so many payment processes. But today we're going to be focusing on the services that we are providing, which is infrastructure as a service, IaaS. So what's an infrastructure as a service? Infrastructure as a service is just a basic, in a simple way, these are all the resources that they provide, they give it to you to use without interfering on how you use it or how you set it up. So their SLA in infrastructure as a service is the physical infrastructure, which is the physical data center, is their responsibility. But everything they have to do with their resources usage or how you did the usage, the configuration, the setup is your responsibility. You understand me? So just see like a custom services where they say, okay, go, you're an expert, go there and you use what you like. And you understand me? If you configure it wrongly, it's your responsibility. If the resources is consuming more, it's your responsibility. If the application is not delivering well due to your configuration issue, it's your responsibility. They may provide you support when you reach out to them. They may provide you support, depends on your package. And sometimes it's mostly free, but sometimes you have to subscribe to higher level. If you want a higher level support, you have to be paid per premium. Now they can just book a meeting with you. If you have an issue, they come up, send up their team to you. They support you, tell you how to do in the best way. And that would be it. You understand? But why would a company employ you is because they expect you to understand how to set up a basic system, how to set up a standard system and a production-based system. And there's no how you talk about infrastructure as a service without talking about storage, compute power, operating system, network, especially network, because network is the basic skill an engineer should have. Whether a DevOps engineer or a cloud engineer, you must have the basic network skill. You understand me? And talking about network in cloud is not a real physical network. It's alike. The setup is like a physical network. So that's why it's because the word like, it look like, and a masquerade like, or should I say, a network that, let me use the word, almost like, you understand me? It exists, but it's not existing physically. That's why they will use the word virtual. Virtual means it's not like it physically exists, but it looks like what exists physically. So when they say something is virtual, means it exists, but it's not something you can physically access. So they design their network in a way, in looking like the physical network. But it's not actually a physical network. It's actually a virtual network. So what does that also imply? It implies because within the AWS or public cloud SLA, they are in charge of the physical network. You are not supposed to go there and interfere into their physical network. And I want to lie to you, the physical network of a data center is complex, very complex. I require experts to work on it. But they try their best to design a replica, a virtual aspect of that same network, so that with a virtual aspect, you can also have that feeling of doing networking. So when you see virtual, V is always more of, when they say their network is basically VPC, for AWS it's called VPC, which means virtual private cloud. And under VPC, they have what we call SBN, which is a portion of a VPC, which is called subnet. That's a sub of the network. You understand me? That's the meaning of the word subnet. Subnet or sub means a portion. Subnet. Then under sub, the word net means network, right? Under subnet, there is another word called route. And I'm just trying to give you the registry because I'm going to be explaining all this thing. I'm going to be seeing it called route. Then under the route, there's what we call ACL, access control list. Then you now have gateway. If you know the word gateway, you should understand the meaning of gateway. Gateway means access, the way it's being accessed. Gateway. And other parameters. So now let's go into networking. So in a virtual private network, according to, it's like, what this is the scenario, this is the analogy. I want to use this analogy. They are saying, okay, you are coming to our house, you are coming to our AWS account, which we know that is a very broad account because it's a collection of so many data centers. So you are accessing it through their website. For you to access it through their network, you want to access all their network, assuming this is their network, they expect you to have a way to connect to this network. For example, this is their network. You should create a path that will be unique to you. That with that path, you'll be able to access what you have put inside their infrastructure. For example, now this is the resources you have put in their infrastructure. This is the resources you want because whenever they give you their resources, their infrastructure, they expect you to be in charge of everything. So this is your resources. Let's assume this is your resources. Now, if this is your resources, you should be able to privately come into your resources without affecting other people also using the cloud. So they expect you to create a path. Let me use the word path. You're supposed to create a path that will connect you to your resources. And this path must be unique, must be private to you. So the process of creating this path and the process of this path also having access to other places, because after you create your resources, your goal is that these resources is also being used by people. You understand me? So people should be able to connect in and out and use this thing that you put in there. Maybe you are creating these resources with you are creating these resources with their infrastructure, as I explained here. These are all their resources. These are all their resources. So this is all their resources. And for you to be able to use their resources, you are planning to use their resources and put your resources inside their own platform. So for you to be successful in creating resources and using resources, you must be able to create a seamless path that is unique to you. So this process of creating this path is called networking. So actually, that is what networking really means. Networking means paths to somewhere. Path, networking. So when you hear the word network, it actually means connection from one place to the other, from one point to the other. That is the meaning of the word network. Why am I breaking it down? Because I know some of us here are not IT people, right? So, but you should know what network is all about. So this part that you use in putting your resources and also the resources having access to other persons to use is called network. Do you understand? Do you understand? Hello? Hello? Hello?
I can hear you.
Do you understand?
Yeah, I do understand.
Yes, we can understand.
Okay. Okay. Now we understand the word network. Now, this in a physical network, there are some parameters, there are some basic properties a network should have. One, a network should have the region it covers, the area, because fine is their resources, but you cannot be everywhere. You understand me? You have to create a part that you can put all your resources within. For example, now, this is AWS, and this is where you want to put your resources, right? This is your network, right? So you must provide, let me put another thing here. So this is your resources. This is where you want to put. You see, from this area to this area is where all your resources is going to be. So in that case, let's just put it this way. Let's just put it this way. Well, let me use the right arrow. I think the arrow, well, I can use this. Okay, good. Do I have any arrow that have two parts? Yes, cool. So this part, see, from here to here is where you want all your resources to be. You can see from here to here is all the places you want all your resources to be. In AWS, this place from this place, all these parts that your network is going to cover, they made it in a way that your only one network that you create will only be available in one region. In one region, yes, must be in one region. So if you want to have all your network in all the regions, you have to create network in all regions. But you can link network in region A to network in region B. You understand now? So, but every region that you want to use your resources on, you have to create a network resources in that region. You can call it highway. So now, but despite you have your resources in that region, you cannot put all resources in everywhere in the region. You understand now? So that particular place that you create, that first network you create in that region is called your virtual private cloud network, also known as VPC. So a VPC is actually a network that you create for a region. But you know, in a region, there is also a sub-region, also known as AZ, availability zone, like I explained before. Let me go to AWS and just show you. show you this. Please, I want you to take note of this. This is what makes you a real DevOps infrastructure engineer. Because if you miss this, so sorry, it'll be difficult for you to really understand. I think I have to log in. Hold on, let me log in first. Let me stop sharing. I want you to take note. I want us to really have do justice to this. Hold on, please. Because after today's class, by the time we talk about other things that people are talking about, you will no longer have issues. Because this is where your work actually lies. Hold on. Am I still sharing my screen? No. Let me be sure. Okay. Let me pause recording. Okay, thank you so much. You can see, even in region North Virginia, you can see this is a sample network that has already been created for you. Every network, every cloud provider will create a sample for you. But you can see they created each, despite they have one subnet, one VPC, they created a subnet in region. You can see even in North Virginia, they have C's, it's almost 6, Nabi. They have 6 AZ, 1E, 1B, 1D, 1A, 1F, 1C. So your network you created in this region will cover all these zones. Meaning, if you have network in this region, you can decide to put your application in either UA East 1E or UAE 1C. This is why they said cloud provide high availability. Because imagine if you have one server here, you have one server here, you have one server here. In case there's a problem in this US East 1E, you can design your application that this 1A will take over the job. It's called using load balancer. Next time you can use load balancer, you can put your application in all these zones and use a load balancer to spread the load so that when one server goes down, another server that is in another region can take over the job. Because you are seeing US 1E now in this place, like as if they are close. They are not actually close. They are far apart. All these zones are far apart. And their power distribution are far apart. Their network model are independent, just that they bridge it using and they use another gate to bridge this A and B together so that all of them can share the same resources. But they have independent network. So if you have a VPC in this region, meaning you can put your resources in either of these sub-region. So this sub-region, the network in this sub-region is called subnet. So you can see a VPC, all your network resources, then your network in each of the zone. That's why they say AZ, availability zone, or known as available zone. These are available zone or availability zone. Available zones are in this region, you have 6. If you go to another region, you see that it may not be up to this. Go to another region, go to Ohio. In South Africa, I think South Africa just have about 4. Did you click it?
No, I just clicked on Ohio.
Okay, you see, it's going to open all the network there too. And it's not advisable to use the default network. You can see in this place, you just have how many? Okay, just take
3.
3.
Just 3. A, B, and C.
So different regions have, some different regions have so many network. Go to Africa, South Africa. Have you enabled South Africa? You've not enabled CTFE.
No, I've not enabled CTFE.
You can go out there. It's a place you can go down and enable as long as you want to. You understand? You can go to manage region. You click manage region, you enable. But let's not bother ourselves with that. But you understand what we are talking about. Now let me go back. For close stop, you don't need permission because you're using an IAM role.
Yeah.
It does not have permission unless you grant that permission. You grant that person that access to that permission. Okay, now let's go back to my class. Because after now we are going to practice. I have already apologized earlier that this will take a little longer class because we need to know this. Please stop sharing. Let me continue. Okay, now we have established the basic networking stuff, right? Now let's talk about, excuse me, I'm still on here. I've opened this. Open it now. What is going with you? There you go. Okay. So I always take my time to do this when it comes to IaaS, because this is the basic things that, okay, now this is it. This place to this place is the region, right? In that region, we call it VPC. On that region, they may different zone. So how do you create this network? You see this arrow you see that we are calling network has an identity. There's a law that binds the security of your identity. That law is called protocol. The protocol is the law that binds the transmission of your network, the rules that your network will follow. I think this is part of protocol, yes. Or I think this is a protocol. And somebody spell protocol again. It's like it's just coming.
It is O, not A.
Yes, protocol, yes. Sorry. Yeah, this is protocol. Just something is clouding my mind on that part. So this protocol is the law that binds so that your own network will maintain your own and go to this place. So these protocols is the rule you must follow. You understand me? So that your line will be straight and your network will go to your place where you are going to. So that protocol, because we are using internet in all our processes, internet means movement from one place to the other. That's why we call it internet protocol, IP. Because internet means internetworking, movement from one place to the other. That is the meaning of internet. So protocol is the law that binds it. It's called IP. When you hear the word IP, the IP actually means the movement from one place to the other and the laws that binds it. It's called IP. IP means internet protocol. It means the law that binds your own network so that your network can reach your place. Now, if we have IP, which I've already explained, we have meaning of protocol now. Now, before, there is a law that there's a body that manages how that law is being organized. You understand me? So they now have to, that body came up with a class. We came up with a rule, different rule. So you may have heard of the word SIDR, S-I-R-O-D, S-I-R-O-D-R. SIDR, if you look at the full meaning of SIDR in internet, is just the way they classify internet provider. So the word SIDR actually means, it actually means classless inter-domain route or subnetting. But you can say this is where SIDR means classless inter-domain routing. So this is the law. This is actually by the body. It's an internet body that designed this law. You understand me? So this IP is not like IP just started now. IP have been upgrading, just the way we also scale in IT. You understand me? We have also scaled IP laws and rules, protocols, like the way we have amendment of Nigeria Constitution. They have been amending it and bringing out different protocols, different rules that network should be moving from one place to the other. You understand me? And that's why we have the version 1, version 2, version 3, version 4. I don't know why is this thing closing? Am I closing it? My presentation, why is it closing? Am I closing it by myself or it's just closing by itself? Okay, let me open it again. So they have different versions. So we have version 1. Version 1 did not really take, you can go and do research on each. Then we have IPv2, but currently we are in version 4 and version 6. Most company uses version 4. In fact, our generation uses version 4 and version 6. So when you hear IPv4, you're actually meaning IP version 4. When you hear IPv6, it actually means IP version 6. And they have a different way they design it. IPv4 is in quadruple, meaning it's in 4-4 group. While IPv6 is also in quadruple, just that IPv6 is not using an octet number. Meaning of the word octet means when you count 1 to 8. From 1 to 8, you will come back again to 1 to 8. So when you say something is raised to power 8, you're talking about octet. Let me not bother you with all those things, but just understand the concept of IT, of IPv. So when they say before, this CIDR is the way they class IP naming. So in that same IP naming, we have 4 versions and version 2, version 3, version 4. We have IP version 1. When you see IP version 1, that's IPv1. We are not using IPv1. We have left all this IP version 2. Those people who are doing physical class IT, they will understand it. But currently, we are now using IP version 4 and IP version 6. When 5G is going to be resting on IP version 6, but some of them are already resting in IP version 4. But more of it is going to be resting in IP version 6, where you now see, most of us have seen this CIDR note. Mind you, I told you that we are doing networking. It's not actually we are doing physical networking, but I just want us to have an idea because cloud networking is actually designed to look like physical networking. So it's going to have the first quadruple, which is going to be 0. The second quadruple, the third quadruple, and the fourth quadruple, slash the last quadruple, which could be 0. So this kind of naming is actually when you use alphabet numbers in 3 numbers, you're actually in, maybe let's use this conventional one that everybody may have known, maybe 192.168.198.168 let's say a 128. Yes, that means slash could be 0 or it could be in the rate of either 4 or /8 or /16 or /32 or /64. So normally, you know, anything slash in numerics, 1/2 and 1/8, which one is bigger?
1/2.
Beautiful. So the more you slide it, the smaller it becomes. But for public cloud does not support /4. Public cloud actually starts from /8. I think, no, does it support /8? Yes, public cloud starts from /8. But mostly we use /16, /32. I think there should be /8. But /4 is so big. You understand me? So most public cloud does not, because it's big. But when you say /0, it means everywhere. So we're going to be talking about this as we are going forward. But when you see a number like this, you look at it, they are actually in octet. 8 can divide them. You understand me? Take note of all this. This is standard networking. But though the public cloud is looking like a physical cloud, but they designed it like form of a physical cloud. But just that in public cloud, you can decide to have a CIDR node of 10.0.0.0/0/16 or /8. You understand me? Or /24 or /0. So you can see, despite we are not really following the standard, you understand me? But you can actually still have the same standard because the same rules applies. But just that they just want you to have this feeling of this networking, because networking, call it virtual networking or physical networking, is actually the same networking. Now, let me also explain this before we go into our practice, because by the time we start practicing, it becomes very easy for all of us. But I don't need to be explaining to you what is this. Now, this is a VPC. Like we have explained now, this is a VPC, which covers a region, right? Now, in this VPC, we have a subnet, a subnetwork, control DDD. Let's assume that this VPC has subnetwork. And we are trying to put this subnetwork in different zones. Now, mind you, one zone can have 5 subnetwork. You understand me? So take note of that. Is the 1, is the 2, is the 3, is the 4. Meanwhile, we can decide to put all our subnets in one AZ, but it's not the best way to work. You understand me? Or this AZ can have 20 subnets. So don't think that if you must put subnet, you must share it in all the AZ. But you can decide to have it in one AZ, but it's not the best way. The best way is actually to share it across AZ. Now, this one explained successfully. Now, this subnet should be able to talk to this subnet, should be able to talk to this subnet, should be able to talk to this subnet. Because why? They are all the same virtual private network, meaning they can securely communicate to themselves. But despite they can communicate to themselves, they cannot communicate outside. So for them to communicate to outside, you must put a gate. Let me use this thing as a symbol for a gate. Meanwhile, there's a standard symbol for it. Let me use this one as a symbol for a gate. For them to communicate outside, you must put a gate here. So this gate that we put here, is just to provide this network, this VPC, to communicate. So how will they communicate? That determines the name of this gate. If we say they should communicate to everywhere, you can actually put a gate called IGW, which is known as Internet Gateway, meaning everybody can enter the network and can also go out of the network. But you can still control how they can have access, just that this network is open to the internet, which basically is, but despite the network have access to the internet, still does not give this subnet the capacity to use the internet. So it does not also give the internet people to have access to the subnet. So that means for this subnet to have access to this internet, it must be able to route out. So you must create a route, maybe also call it a path. Let's use this one as a symbol for route. To use this gateway, you understand me? You can decide to do it. So when you do this, it means that this subnet now have access to this internet, meaning internet can come in, this subnet can go out. If you make it open, this subnet becomes a public subnet. Why is it called public? Is because it can have access to the internet. Internet can also have access to it. Then, meaning in this routing that you are going to do, you are going to put internet gateway to this routing. So despite this subnet has internet, this VPC has internet gateway, it does not mean that all these subnets will have internet gateway. So for it to have internet gateway, you must create a route table. That routing table, you attach an internet gateway to it. What about if you now create a routing table and you did not put an internet gateway to it? Maybe you create a routing table. Let's tie it here. And that routing table, you put another gateway, because you can decide to put internet gateway to have direct access. You can decide to filter the internet that the subnet will be able to get to the internet, but internet will not be able to get to it by putting a translator. We call it network translator, NAT, network access translator. Maybe some of you have heard of the word NAT. So it's just to translate the network so that the network, maybe there's a resources inside this, maybe you put server inside this network and you want that server to go to the internet and update, maybe patch, you understand me? But you don't want the internet to come into it. So you put a translator here into this routing table. So it's from this routing table that you control how access can come in. Yeah, maybe I just mentioned here when I was talking about route, right here, routing. So is this route table, also known as ROTB, that you control how access to the internet or how the gate is. This routing table, this is where you put your gate. This is where you tie your gate to. Then the ACL is the listing, the way you control how even that gate will be able to connect to outside or coincide. It's called access control list. It's like a firewall. Mind you, all these things they're not really like a firewall. They are like a network model. Are you getting me? That have access in and out. Because you cannot decide to do, firewall is mostly tied to application. It's not mostly tied to, I say application, yes, mostly application and virtual machine. So just have an idea that in the VPC, there's a routing, there's a subnet, which is tied to a zone. A VPC is tied to the region. A routing table is tied to the zone. Because from the routing table, you can list, you can tell whether the subnet to go into the internet or not. Then from the routing table, you can actually control the access to it. So we are talking about networking here. So a gateway is how you want the subnet to be communicating, or how you want the network to be communicating. If you want it to be communicating to the internet, we call it Internet Gateway. You can actually create another gateway called a virtual private gateway, also known as VPW. When you want to connect your one VPC to another VPC. You understand me? If you want to connect, maybe you have one VPC here, and you have another VPC in another network. You want the VPC A to talk to VPC B, you pair them. Most times you use virtual private gateway to pair them. So if you want, what about a physical, somebody have a data center or a company have a network already in their physical office, and they want to tie that network, that VPC, to public cloud. You can also do it using what we call VPN, virtual private network. That means you now link the virtual network you have and the physical network you have, you link them together. You understand me? That's also known as intranet. So I'm going to be talking about that. So all these things I just talked about, please try and play this video again. All these terms I'm using, write it down because they form the basics of your work. As a DevOps engineer, you must use them. You must know them. You must. Because some company will have their physical, they have server in their office. They want the server in the cloud to be communicating. So you have to know how to set up the network so that both of them can communicate. The reason is because they don't want to pass through the internet. Because when you pass through the internet, there can be a cyber security, it's a cyber breach. You understand me? It's going to, and the level of transfer, you know, because it's passing through the internet, it's going to be passing through a tunnel and it's going to take time. So when you bind it to your local, for example, if you want to transfer a file from your storage data center to cloud, if you are taking through the internet, it's going to take a long time. And you're going to follow packages, you know, because you're going to transcode, decode, all the stress. So all you just do, just pair your data center to your cloud and just transfer your file. So it's going to be faster. Understand me? Using some AWS have a feature called DMS. Understand me? Database migration services, data migration services. So that is for that. Coach, I will watch the video tomorrow. Please make it available. Yes, you will have it. You have it. Okay. I've spent so much time. Okay. Now let's just continue. Or I think today we can stop here. Tomorrow we start set up and we'll put our server on it, right? Can we do that? Can we stop here today? Or should I still continue? Hello? We can
Let's stop it today. I'm already tired.
Okay. Sorry, is it too big? What I was saying, is it too?
It's not out of scope. At least I might have some little idea about what I've been saying. So at least some points.
Okay. Is anybody that's trying to catch something that is looking so hard?